Hi everyone, welcome to the walkthrough and explanation for Lab 1. This lab, it looks like this, and it's aimed to try and get you to be familiar with maps and how you find yourself on a map and how you can understand direction and distance on a map. So you have these questions to answer, and then this rudimentary topographic map that has a couple of buildings on it. It has ground contours showing you the height of the ground, and it's got a footpath and a north arrow and a scale alongside a grid, which should have all of the components you need to understand where you are on a map. And then this thing at the bottom, we'll use this to construct a hill profile, which is the first step in drawing a cross-section. Okay, so this first question asks us to mark a point and label it with the letter A, the position of the place on the map with the reference 479495. Okay, this is what we call a six-figure grid reference, and you can split it into two parts. The first three figures are the X coordinate, and the second three figures are the Y coordinate. So it's saying 479 on the X and 495 on the Y. Now you can see that we've got this grid going around the outside of the map. 460, 470, 480 along the x-axis, and 470, 480, 490, 500 on the y-axis. So our first grid coordinate, this 479, would be within the 47 box, or between the 47 and 480 part of the x-axis. So what we can do is separate out these grid squares into smaller components. We can decimalize these grids and turn each one of these big grid squares into 10 smaller ones. So our grid reference 479 is going to be somewhere in here, and then 495 is going to be somewhere in here. So that grid square that we're going to exist in is this one. So let's decimalize this grid square and make it more precise as to find where we are. So we've turned this grid square into 10 smaller ones, 10 subdivisions in the x-axis and in the y-axis. So now what we can do to find ourselves is just count along from 4, 7, 9 of these smaller subdivisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you go to our y coordinate, which is 495, so count 5 up from our 49 grid line. So 1, 2, 3, 4, 5. So that's where A is going to be on our map. The next question asks us to give the six-figure map references for Ashton Lodge and Oxley Farm. So these two buildings, Ashton Lodge and Oxley Farm. Let's start with Oxley Farm first, and then do what we did in the last example and separate our grid square into 10 smaller subdivisions. And now that we've got our finer, more precise grid, we can just do the same thing as we did before, but count backwards, I guess. So we're in the 480x. 1, 2, 3, 4, 5, 6. So our x coordinate for Oxley Farm would be 486. And our y coordinate, this is at the 480 y line. So we go up 1, 2, 3, 4, 5, 6, 7, 8. So 488. So that should be 486, 488, which is the grid reference for Oxley Farm. And then Ashton Lodge, we can build another one of our subdivisions, and this time we can count backwards from our 460 grid line. So taking one increment back on the x-axis would make this 459, and then counting up from our y-axis at 490 would become 1, 2, 3, 4, 5, 6, 7, 8, 9, 499. So our six-figure grid reference for Ashton Lodge would be 459499. The next question asks what the straight line distance is between Ashton Lodge and Oxley Farm. Well, the first thing that we need to do is figure out what the scale of the map is. And up in the top right here, you have this bar which says that this distance on the map is equal to 500 meters in real life. So that's what we call our scale bar. So what we should do is get a ruler and measure the length of that scale bar, and we can measure it as being 25 millimeters. So what that's saying is 25 millimeters on the map is equal to 500 meters in real life. Therefore, if we wanted to find out how much 1 millimeter is, we divide that 500 meters by 25, the length of the scale bar, and then that tells us that every millimeter on the map is 20 meters in real life. So once we've got our scale factor, we can start using that to work out what distances are on the map. So our question is asking us to find the straight line distance between Ashton Lodge and Oxley Farm. So we can draw a straight line between those 2 points. Then we can put our ruler along that, and we can see that that straight line distance from Ashton Lodge to Oxley Farm is 145 millimeters. Now, to convert that distance into a real life distance, we multiply that number of millimeters, that 145, by the scale factor, which in our map says that 1 millimeter is 20 meters. So we take that 145 and then we multiply it by 20, and then that gives us a straight line distance of 2,900 meters. The next question is asking us what the distance between points with the coordinates 473, 470 and 463, 591 are. And what you can see is that we can't use a ruler for this question because the second coordinate is too far north. It's not on our map, so we can't put a ruler between them. But what we can do is use Pythagoras' theorem. And what we have for these two coordinates, we've got 473, 470 here, and then we've got 463, 591 up here. So what we can do is take the difference in the easting coordinate, so take 463 from 473, that tells us that that distance is 1 kilometer. And then we can take the difference in the y coordinate, which is 591 from 470, and that tells us that that distance is 12.1 kilometers. And hopefully you guys remember from GCSE maths that Pythagoras' theorem says that the square of the hypotenuse is equal to the square root of the sum of the squares of the other two sides. So what we do is take 1 squared, add it to 12.1 squared, and then take the square root of that, and that gives us our hypotenuse distance, our straight line distance between those 2 points, working out as 12.14 kilometers. The next question asks you to work out what a compass bearing from Oxley Farm to Ashton Lodge is. And what the key thing to remember with bearings is that they're always measured as a 3-figure number, always clockwise from north. So if we were stood at Oxley Farm and we wanted to take a compass bearing to Ashton Lodge, what we should do when measuring on a map is position where north is, either by drawing ourselves a line or just remembering the direction that north is, usually given by our north arrow. Draw a line to the point of interest, so we're at Oxley Farm and we want to know the bearing to Ashton Lodge. And then we count the degrees bearing clockwise from north. And that gives us a bearing of 293. So the angle between Oxley Farm and Ashton Lodge in a clockwise direction is 293 degrees from north. This next question is asking you to mark on the map the point that is 2,600 meters from Ashton Lodge on a bearing of 170 degrees north, and to label this point with a letter D. So the first thing that we need to do is figure out what direction we should be heading in, and then we can figure out how far we need to go. So again, we orient ourselves with north from our starting location, which is Ashton Lodge. Then we count clockwise around from north 170 degrees, which takes us there. And that says that the point on the path is in that direction. The next thing that we need to do is figure out just how far along that heading we need to go in order to reach 2,600 meters. And hopefully you guys remember from question 3 that our scale factor of our map, or the distances on our map, can be worked out by understanding that 1 millimeter on the map is equal to 20 meters in real life. So to figure out how many millimeters on the map 2,600 meters is, we take that 2,600, we divide it by 20, and that tells us that we'd need to travel 130 millimeters on our map. So we can line up a ruler parallel to that bearing and then mark on 130 millimeters away this point D. Okay, the next question says that a walker on the footpath takes a compass sight on Oxley Farm and finds the bearing to be 078 degrees north. Mark his position on the map with the letter F. So you've got a guy who's on the path. He takes a compass bearing to Oxley Farm from where he is on the path, and he finds the bearing is 078 degrees north. Okay, well, the thing to remember for this question is that the bearing from yourself to something is going to be 180 degrees different than the bearing from the thing you're looking at back to yourself. So if the bearing from the walker to Oxley Farm is 078 degrees, then the bearing from Oxley Farm back to the walker will be 078 plus 180 degrees, so 258. So if the Oxley Farm is at a bearing of 078 from the walker, then the walker is on a bearing of 258 from Oxley Farm. So we add a north arrow to Oxley Farm, and then we count around clockwise 258 degrees, and we know that the walker must be in that direction from the farm. Now if the walker is on the path, then their location exactly on the path is the intersection between the path and that compass bearing. So we can mark his location on with an F. This next question says that a geologist wants to locate a rock exposure she has stood at on the map. From the exposure she takes a compass sighting on Ashton Lodge and Oxley Farm and obtains bearings of 315 degrees north and 020 degrees respectively. Plot the position of the exposure marker with letter H. So we have a geologist who's on a map, isn't quite sure where she is on the map, but has taken compass bearings of 2 locations. So by using the bearings to those 2 locations, she should be able to triangulate her position. So again, just like the previous question, if the bearing from the geologist to the farm is 020, then the opposite direction from Oxley Farm back to herself is going to be 020 plus 180. So she's going to exist on a bearing of 200 degrees north from Oxley Farm. So we line up a north arrow and count around clockwise 200 degrees, and we know that our geologist must be somewhere along that direction from Oxley Farm. Now to narrow down exactly where she'd be on that bearing, she's taken a second sighting off Ashton Lodge and has found that the bearing from herself to Ashton Lodge is 315 degrees north. So again, if the bearing from herself to Ashton Lodge is 315, then the bearing to herself from Ashton Lodge is 315 plus or minus 180. So it gives her 135. So we put an arrow on Ashton Lodge and count around 135, and we know that the geologist must be on that bearing. So the only place that she could possibly be is the intersection of those two bearings. So her location we can mark as H. Next question is asking or stating that the perfect picnic spot is one on a south facing slope. Mark with a letter P the best available spot on the map. So these black dashed lines are showing you the ground contour, so they're joining points of equal height above sea level everywhere in this map area. So everywhere along this line, for example, is at 1000 meters, and everywhere along this line is at 600 meters. So obviously there's a gradient. You start off high over here and you start going downhill in this direction. You're losing height. So this particular part of the slope is sloping towards the northwest. Okay, so the only place that has contours which would slope in a southerly direction, from as far as I can tell, is near Ashton Lodge. So the best place for a picnic on a south-facing slope can be marked between these two contours, which are sloping towards the south. Okay, the next question is asking what is the angle of slope of the ground in degrees along the line of the path at point 480, 480. So at point 480, 480, 480 on the x and 480 on the y, we're at this part of the path. And you can see that along this path we start up high at 800 degrees in this particular section and then slope downwards in this direction towards the southwest as we travel down the path. So what we need to do to work out a gradient for the path in this location is find 2 points along the path around here that we know the height. So for example, at this point we know the height of the path is at 480 because the height of the path is sat on the 800. We know the height is 800 because the path hits the 800 topographic contour, and we know here that the height of the path is 600 because it hits the 600 meter topographic contour. Okay, so we've got these 2 points where we know the height of the path, and then what we need to do is figure out over what horizontal distance this 200 meter change in height occurs. So we bring back our ruler, and that tells us that the map distance between those 2 points is 63 millimeters. If every millimeter on our map is 20 meters in real life, then the real horizontal distance between those two changes in height is 63 multiplied by 20, which is 1260 meters. Then what we can do is use simple trigonometry to figure out the angle of slope along this part of the path. And if our angle of slope in this diagram is given by x, and the opposite side of our triangle is given by this 200, and our adjacent side of our triangle is given by 1260, then we can calculate the size of x as being the inverse tangent of the opposite over the adjacent, which gives us an angle of slope of 9 degrees. This next question is asking us for the true slope of the ground in degrees at 480, 480. So in the same place, what is the true slope of the ground? And what we mean by the true slope is the steepest route down that slope. Now the steepest route down any slope is perpendicular to the ground contours. You can imagine that if you were stood here at 800 and went down to 600, the quickest way to do that would be to walk perpendicular to the contours in this direction. So what we can do is work out the heights of 2 points along that slope direction and measure the horizontal distance over which that change in height occurs. So again, here we're on the 800 meter contour line, here we're on the 600 meter. That change in height occurs over 25 millimeters. So to work out the real horizontal distance for that change, we multiply 25 by 20 to give us a real horizontal change of 500 meters. Then again, in exactly the same way we did for the previous question, we can use simple trigonometry, build ourselves a right angle triangle which says that the angle of slope is equal to the inverse tangent of our change in height over our change in horizontal distance. So in this case our change in height is 200 meters, and that occurs over 500 meters of horizontal distance, and the inverse tangent of that ratio gives us 22 degrees. Question 12 asks us towards what direction does the ground slope at 485,475. So we can first locate ourselves by subdividing our grid into a more precise smaller grid with finer intervals. And we can see that 485 is at 480 on the x-axis, 1, 2, 3, 4, 5, and 475, so 470 y line, 1, 2, 3, 4, 5. So this is where the location is. And like I said in the previous question, the sloping direction of the ground is taken as being perpendicular to the ground contours, travelling from high to low. So at 485, 475 the ground slopes towards the northwest. We start off on high ground in the southeast and we go to low ground in the northwest, so the sloping direction is towards the northwest. Okay, the next question is asking to draw a topographic profile between 480, 470 and 460, 500. So we've got two coordinates which mark either end of the place that we want to draw a topographic profile for. So what we can do is take a strip of paper and mark along that strip of paper the start and end of our hill profile, so 480, 470 and 460, 500, and mark along everywhere that that strip of paper along that orientation crosses one of our contours. So you can see that everywhere along this strip of paper I've marked on where we've crossed a ground contour and given it a label. Then what I can do is take that piece of paper, line it up with the hill profile panel that we've been provided, and transfer from my strip of paper the ground contour heights at the correct position and mark those on my topographic profile. So my strip of paper with my ground heights, all I've done is taken those ground heights and placed them on the topographic profile panel at the appropriate height. You can see that this one at 800 is at 800 on the panel, 600, 400 and so on. Then what I can do is join the points together with a line that represents the hill profile, and as I'm doing this, I'll have to interpret where the valleys are and where the hill crests are. But what I can't do is ever cross one of these main topographic contours which I didn't cross when I was marking them on my strip of paper. And that's the end of the lab. So the end of your lab, it should look something like this. And if you're happy enough with this lab, then I think we can move on to the next one, where we start drawing some horizontal and vertical geology. Okay, thanks for listening. See you in the next lab.